anyone has any specific things they want to go over, feel free to let me know. Otherwise, I'll be able to hang around for a little bit after the lecture if you want to put any questions. But let's just go over a few things. So, format is the same as previous 210. Same as last 210. So there'll be 4 questions, most of which will have a sub-question. There will be two sub-questions. If it's a long question, maybe it'll be just one for the whole thing. So similar to the last ones. I can't remember off the top of my head exactly how many individual questions there are, but it'll be almost 8, I guess. Anyway, so very similar to the last ones. It will cover weeks 7, 8, and 9. So the topics that we did during those weeks, I'll just go over those and maybe talk very quickly about the things to do. So we'll have limits and continuity. So you should sort of know for this what a limit is and how we might sort of look for it. Things like finding limits at infinity, ones, sort of rational ones, how we might cancel, stuff like that. And also what it means for a function to be continuous. So we want to make sure that the function value at every point is equal to the limit at that point. So there's a few things in the practice tests and in the tutorials and stuff that will give you some ideas of what to look at there. So differentiation. So you should know the basic derivatives off by heart. So there was that table that we gave you. I think the last 4 or so were a little bit exotic and I probably wouldn't expect you. But you should know how to find the derivative of just like x to the n, ln of x, sine, cos. Those are the basic ones that you should just know off the top of your head. Those won't be given in a table. So basically I'll say this now, the formula sheet will be exactly the same as what's in the practice tests. So it will cover the rules of differentiation, the product rule, quotient rule, chain rule, but the basic ones you should know. So the ones I just said, I consider the basic ones. Okay, so that includes implicit differentiation, how to find slopes at points. So how to find an implicit derivative and how to use it to find slopes at a particular point. So product rule, quotient rule, chain rule. First derivative test is how to do that. So I have had a few questions of can you use the second derivative test. Some people have used that in school or maybe in other courses where you look for a second derivative to tell us something's a maximum or a minimum. Basically, the answer to that is essentially no. One, we didn't cover it in this class, but a better reason will be because I'll always use the first derivative test in the question just to remove any doubt. So if it says use the first derivative test to find maximum or minimum, and you use the second derivative test, you can't expect to get full marks for that because the question would explicitly say. Okay, so that's basically the basic things to know for that. The other things we did during those weeks for the algebra side were linear systems. So linear systems, so how to solve with inverse matrices. So that was one of the methods that we saw. And also how to row reduce. And so that means putting it in reduced row echelon form, and how to find solutions from the reduced row echelon form. So unique solutions and no solutions are really straightforward. If there's infinitely many solutions, you've usually got a little bit of work to do. But if you know what you're doing, it's pretty much the same way the whole time. So you should know, if you're looking at a matrix in reduced row echelon form, you should immediately be able to tell what the type of solution is, and you should be able to find the solution as well. Okay, so that's in a very broad sense, what we covered. So there will be, like I said, a formula sheet, but it will be, so we're a bit more limited because I don't think there's as many formulas that you really need for this one. But if you're not quite sure what's in it, have a look at the practice tests on Blackboard. It'll be the same as that, or at least everything you need from that. Okay, so does anyone have any specific things they want to go over in the last few minutes from the, yeah? From this week's tutorial? Yeah. Okay. Use the first derivative test. So use first derivative test to find local maxima and minima for the function, called I here, but I'll call it f of x equals sine of x plus x. Okay, so just a little disclaimer at the start. If you had your tutorial earlier in the week, it was pointed out to me that the answer that I gave to the tutors was wrong, and it most definitely was. This is quite a tricky question, and I was sort of daydreaming a bit when I did the answer. So if you had your tutorial earlier, you may have been sort of told slightly the wrong thing, but listen up now, and this will be the definitive version. Okay, so this is going to be quite tricky because, firstly, there's going to be infinitely many critical points. So we're not going to be able to just step by step apply the method, but we've got to think about what's going on here and how we might look at it. Okay, so I want to use the first derivative test. So what we need to do, firstly, find critical points. Okay, so critical points will be points where it's not differentiable. So not differentiable. But this one, sine x is differentiable everywhere, just x is differentiable everywhere, so there's going to be no points of this type. Okay, so now we need to find where f dash of x equals 0. So f dash of x equals cos of x plus 1. That equals 0. So we need to know that's where cos of x equals -1. Okay, so this is going to rely a little bit on your knowledge of the shape of the cos graph. So like I said before, this question is
-1 equals x.
It's tricky, and it's one of sort of
if you go from
probably
cos to
trickier than you can
sine,
expect in the test,
if
but
you
it's
go
sort of
to
designed to make you
differentiate
think
cos, then
of
it's
it
negative
in the
sine.
tutorial.
No.
So cos is going to look
If you
something
go-
like this.
If you differentiate sine, it's a
So
cos.
it's 0 to 1 there.
I mean, like,
and
if
then
you
it goes
can't you
down
just go cos inverse -1 equals x?
goes down to -1 and pi comes back up. And also comes down, goes -pi, and it'll come down back there.
Also,
and,
Because cos means nothing with sine
so
without the
that's
x.
going to be, that's 2
No,
pi, it's going to be 3
inverse
pi,
cos
and then
-1.
-3 pi. So basically at
In the
all
bracket,
odd,
-1.
oh, sorry, yeah, at all odd multiples of pi, so pi, 3 pi, -3 pi,
Right.
cos of x is going to be equal to -1. So at odd multiples of pi, cos of x equals -1. So that'll mean that cos of x cos of x plus 1 will be 0. So then these will be our critical points. So these will be critical points. guarantee that cos of x plus 1 equals 0, because cos of x is 0. So it's going to be odd multiples of pi, so 2n plus 1 pi for n and z. That's just a fancy way of saying odd multiples of pi. So those are our critical points. Now we need to know whether they're local maxima, local minima, or neither. Or maybe some of them are one and some of them are another. Okay, but let's just have a little bit of a think about what the first derivative test is telling us. So the first derivative test tells us if the derivative on one side of a critical point is positive and on the other side is negative, then it's going to be, well, if it's positive on the left and negative on the right, it's going to be a maximum. If it's negative on the left and positive on the right, it's going to be a minimum. So if it doesn't change sign, so if it stays positive on both sides or stays negative on both sides, it's going to be neither. So it's not going to be
Straight line.
maximum or a minimum. But if we have a little look about what this f dash x is going to be cos of x plus 1. But because cos of x only ever stays between negative 1 and 1, that means cos of x plus 1 is going to be, is only ever between 0 and 2. So it's only ever positive. So therefore there can't be any local maxima or local minima because it can never go from positive to negative or negative to positive. So it can never go plus to minus or minus to plus. So no local maxima or minima. Okay, so this was, as I said, quite a tricky question, and to be honest, this would be at the very, very, very hard end of something you could expect in the test. So if you had this in the test, everything else would be a lot easier. I'm not going to say you'll never get it, but it is a very hard question.
What's the test?
I
So that's
recognise
what.
that. But I guess the idea is to get you thinking about these things. This is sort of how you
Correct. Yeah.